Good morning, ladies and gentlemen. Today, I'll be talking about an instrument which is there inside the aircraft, which we call it as a inertial navigation system, or in short, INS. Inertial navigation system. It is an instrument which measures the velocity and the position of the aircraft at any given instant. The beauty of this system is that this instrument can find out the position and the velocity of the aircraft without any external input. It is a self-sufficient system which finds out the position of the aircraft. Before I go on to the working principle of this inertial navigation system, I will bring you back onto your school days. Whereas in your school, we all have learned about what an acceleration is, what a velocity is, and what a displacement is. So when I say the word displacement, it is a vector quantity. So what is a vector quantity? A vector quantity will give you the magnitude and the direction of the motion, whereas the scalar quantity will give you the magnitude only. For example, my aircraft is flying at a speed of 200 knots. So this does not give any direction on which the aircraft is going, so it becomes a scalar quantity. The moment I say that my aircraft is going on a 090 direction with a speed of 200 knots, then this becomes a vector quantity and it becomes the velocity. The velocity is defined as the rate of change of displacement. So therefore, V velocity is defined as the rate of change of displacement. And we also have learned that acceleration is equal to rate of change of velocity. Therefore, it is velocity upon time. So if I replace the value of v in this formula, now what I get is acceleration is equal to displacement upon time multiplied by 1 upon time, which is equal to distance upon t square. This is acceleration. So primarily, there is one component inside the inertial navigation system which measures the acceleration of the aircraft. The name of the component is, we call it as a accelerometer. Once I find out the acceleration of the aircraft, from this formula, I can find out the velocity, and also with the knowledge of the velocity, I can find out the displacement of that particular aircraft from the original or starting position. So now, how does an accelerometer look like? Accelerometer. Now let me construct a box. This is a box, say, which is fitted inside the aircraft. And in this box, I have a mass which is suspended with the help of a spring this side and with the help of a spring this side. This is the mass. So now, if the aircraft accelerates in this direction, the frame also will move along with the aircraft. However, because of the inertia, there will be a lag in this mass. So therefore, the mass will move direction opposite to the direction of acceleration, thereby compressing this spring and expanding this spring. The movement of this mass opposite to the direction of the aircraft motion will be directly proportional to the acceleration of the aircraft. Now, I can find out by how much this mass has moved towards this direction, and I can measure the acceleration of the aircraft because the motion of this mass will be directly proportional to the acceleration of the aircraft. In order to have a very sensitive equipment, I should be able to pick up a minute change in the displacement of this mass. Now, the disadvantage of such a system is that if I have a very tight spring, because of the spring tension, I will not be able to detect a minute or a very small amount of acceleration. In that case, my system will not be a very accurate or sensitive system. And if I want to measure the acceleration very accurately, then thereafter, then the spring has to be very soft. If the spring is very soft, the mass will hit the wall when the aircraft accelerates very fast. So therefore, I should have a very long tube, which is impractical to feed in the aircraft. So therefore, I will develop another accelerometer, which is known as the pendulous type of accelerometer. And let's see how does it look like. Now let us say that this is a box, a frame, which is there fitted inside the aircraft. In this frame, we will have a pendulous suspension of a soft iron material. Now I will have a E bar here, again made of a soft iron material. This E bar is excited with an coil. Now I will have a pickup coil here, another pickup coil here. From this excited coil, this pickup coil will be energized and there will be an EMF which will be generated in this pickup coil, and a similar amount of EMF will be generated at this point. Since the displacement of this E and the I bar here, the pendulum, this is what we call it as a section of I bar, the amount of EMF generated will be the same because the displacement remains the same. So if I connect these two, there will be no potential difference and there will be no flow of current when the pendulum is in the null position. The moment the aircraft accelerates, say in this direction, the frame will move into this direction. Because of the inertia, the pendulum will lag behind and the pendulum will be displaced. If the pendulum is displaced like this, the distance from this pickup coil has become lesser and the distance from this coil in the I bar has become increased. So therefore, the EMF which is produced by this pickup coil, picked up by this pickup coil, will now be different EMF. So since the EMF is different, there is a potential difference. There is a potential difference. So now electric current will pass through this circuit. This particular EMF will now be fed into a computer, and through this computer, it will be amplified. And this amplified electrical signal will be used to drive back the displaced pendulum through a coil once again. So through this coil, okay, I will be pushing this pendulum back to the original place. That means to say that I will be applying a force to push this pendulum back to the original position. The amount of force which is required to push this pendulum back to the original place that force will be proportional to the acceleration of the aircraft. This force applied can now be calibrated and the display or measured in terms of acceleration of the particular aircraft. This is the function of an accelerometer which finds out the acceleration of the aircraft. And from that formula, what we said that was velocity is equal to displacement upon time, and we know that acceleration is equal to velocity upon time, and acceleration is equal to d upon time multiplied by 1 upon t. This is from the basic formula, right? So from this formula, what we are trying to find out is, if I know the acceleration, can I find out the velocity of the aircraft? I know the time, I know the acceleration, I can find out the velocity. Once I know the velocity, can I find out the displacement of the aircraft? How far the aircraft has gone from the original position? Isn't it? So now let us say that if you start from this position and you start accelerating towards this direction, and if I can calculate the acceleration, I can find out the velocity in this direction, am I right? And I can also find out the displacement in this direction. So it is as good as finding the position of the aircraft from the starting point, right? So this is what INS does it. Now, let me complicate the issue a little bit. In order to have a very accurate measurement of velocity and a very accurate measurement of the displacement, which is very, very important, am I right? So what I need to do is, I should be able to measure a minuscule amount of acceleration which is experienced by the aircraft. In mathematical term, the minuscule amount of measurement of a very minuscule amount of is what we call is a derivative. Do you know the calculus? You have learned calculus, right? Isn't it? If I have to measure in a very, very small amount of acceleration, it can be said that it is the delta acceleration, right? Or in case if I measure a delta acceleration, it is going to be I will be able to find out a very accurately a minuscule amount of velocity with respect to time. In the same formula, if I replace it velocity by this is nothing but your very. So by knowing this very minuscule amount of acceleration experienced by the aircraft, if I integrate this, the first level of the opposite of differentiation is integration, am I right? If I integrate this, I will get the velocity. The first integration of the acceleration is going to give me the velocity of the aircraft, and the second integration is going to give me the displacement of the aircraft. So therefore, the basic principle of operation of an INS is find out the acceleration. The first integration will give me the velocity, and the second integration will give me the displacement. So therefore, it is double integration of acceleration to find out the displacement of an aircraft. So therefore, the principle of operation of INS is double integration of acceleration to give displacement. So in today's class, we have learned about the basic principle of INS, that is the Inertial Navigation System. In my next class, I will talk about how the integration of acceleration is done to give you the velocity, and the further integration of the velocity to give you the
displacement. So stay tuned for my next class. In that, I'll be explaining about how the acceleration is integrated. Thank you, ladies and gentlemen, for supporting my channel. If you are new to this channel, kindly subscribe, like, and share it to your friends. Thank you. Have a nice day.